we're going to talk about scales and how to analyze them. So let's just start with a scale that's pretty common. This is the Big Five inventory. This is the free measure of the Big Five that most personality psychologists use in their research. And you'll notice there are 44 questions on here that I am not reading them all, okay? Are they talkative? Are they depressed? Blue is original, comes up with new ideas. I see myself as someone who is talkative, who tends to find fault with others, who, right? And you see there's 44 different items here, okay? And so when you look at the scoring, you'll notice there's not just one item. There's a score for extroversion. There's a score for agreeableness. There's a score for conscientiousness. There's a score for neuroticism. There's a score for openness. This scale has 5 latent factors underneath it, 5 components, 5 factors that it is examining. It's examining extroversion, agreeableness, conscientiousness, neuroticism, and openness. Okay, that's important to know. I'm going to show you how to examine a scale for factors today. Additionally, right, I got to point out that you have some items that are reverse scored. Let's just take extroversion. Extroversion item 6R. So extroversion, right, like you know what an extrovert is reserved. Well, that does measure extroversion, but if you're high on it, you're low in extroversion. So we have to reverse score it. I've already told you about reverse scoring if anybody watched my SPSS video, but essentially to reverse score this questionnaire, if a participant gets a 5 on question 6, we should rate them as a 1. If they get a 1, we should rate them as a 5. If they get a 2, we should rate them as a 4. If they get a 4, we should rate them as a 2. And if they get a 3, we should rate them as a 3. Mathematically, the easiest way to do this is to always take your highest number on your scale, add 1 to it, so in this case 6, and subtract your score from 6. So 6 minus 1 is 5, 6 minus 2 is 4, 6 minus 3 is 3, 6 minus 4 is 2, 6 minus 5 is 1. That's the easiest way to reverse score. But, so I want you to know that, like when you're looking at your scales for your data, you might have, I'm going to tell you right now, a lot of folks just enter them wrong. A lot of folks went in there and they just averaged everything together. They didn't look at the codes and they don't have a measure of extroversion. They don't have a measure of what they want. So double check what you did with your scale. Uncle Brian wants you to double check what you did with your scale for your data analysis. And if you messed up, I want you to redo it for your poster, okay? It's okay. I don't believe the posters are being printed. I really hope not. That would be the worst idea ever. But if they are, they are. And if it's too late, they're too late. But it's not too late for us to find the correct answers, okay? So first thing you had to understand was that there's different factors to this scale. I'll show you how to get that. The second thing you have to understand is that there are different ways to calculate different different subscales. So like this R right here means reverse score number 6, reverse score number 21, reverse score number 31. We average those all together to get our score of extroversion. If we didn't reverse score, we failed. And then the final thing is like, okay, we're coming to analyze this, right? We're going to do 2 things. We're going to check if the factor structure is the same as the authors suggest, which is totally fair. It's totally fair to check them up on it. And we're going to check within each of these subscales. And we're just going to do it and you'll see we're going to do it in a much smaller data set. But we'd want to make sure that the items in this subscale have a high, are highly correlated. So answers on item 1 are highly correlated with answers on reverse scored item 6, which are highly correlated with 11, 16, reverse 21, 26, reverse 31, reverse 36. So what we do is we calculate a Cronbach's alpha, which is basically the average of all these correlations. It's not exactly the average, but it's basically the average of the correlation between item 1 and item 6 reverse, item 1 and item 11, item 1 and item 16, item 1 and item 21, item 1 and 26, item 1 and 21 was reversed, item 1 and 31 reversed, item 1 and 36, 6 reversed in 11, 6 reversed in 16, 6 reversed in 21 reversed, 6 reversed in, you get my point, I think, right? So we need to calculate that Cronbach's alpha when we need to check our factor structure of our scale. So what I'm going to do is just no PowerPoint today. I'm just going to move right in to our our stats program, and I made a horrible scale, right? I made a horrible scale that I just wanted to test to see if it had good Chromebox Alpha. It's just a scale for us to test, okay? So you can see here I asked 5 people, how happy are they? How peaceful are they? How sad are they? And how anxious are they? This is my happiness questionnaire that I made up. I chose for some reason not to go with the happiness questionnaires that exist. Some of you did the same. Now I have to deal with that problem, okay? My first thing I want to do is I want to create a data frame that puts these all in like a Excel sheet for R. So now I have my data all together. And then after that, what I'm saying here is I'm creating a variable called alpha stats that is taking this alpha function that takes my data and these keys, which reverse score items 3 and 4, which are the how sad and anxious you are, to calculate my Chromebox Alpha. And then from that, so let's just go ahead and run this real quick. And we're not going to look at everything because we got outputs that we're not going to interpret, or it just hates us today, I guess. I'm waiting for RStudio Cloud. Hopefully it shows me my data here in a second. Come on. You know you want to show it to me. You know you do. All right, I'm going to close this, and I'm going to rerun it, and then it's going to show it to me, I bet. Or at least it's going to tell me if it's disconnected. All right. So I'm just going to go. If this happens to you, I'm just going to reload. Everything's saved. Sorry about that, but sometimes you get these little errors and stuff, but this is how you deal with this particular one. All right, so we're going to run this analysis real quick just to show you the Chromebox Alpha, how to interpret it, what the statistics are. So my Chromebox Alpha is 0.9. So that's your first step. So those 4 items are highly intercorrelated. On average, you're correlated by 0.9. Those 4 different correlations that we would have, I think. Maybe even a lot more than 4. Yeah, maybe like 5 or 6. So all the correlations between item 1, 2, 3, and 4. So item 1 and 2, item 1 and 3, item 1 and 4, item 2 and 3, item 2 and 4, and item 3 and 4. So that's 6 total correlations. The average correlation with some correction is 0.9, which is a massive correlation. That tells us that these items are highly correlated, and guess what? They're the same scale. If your Chromebox Alpha is 0.7 or above, don't touch any of your items. But if your Chromebox Alpha is less than 0.7, you're going to look at the next table. The next table right here tells you your Chromebox Alpha items are deleted. So if your Chromebox Alpha improves drastically by deleting an item, you know that that item is kind of hurting the scale, is not really fitting in with the other items. So when we look at this, we see that question 2, if we remove that item, our Chromebox Alpha would become 0.97, which is massively high. Now, we wouldn't actually remove it in this case because our Chromebox Alpha was 0.9 to start, right? But if it's less than 0.7, we're going to look here to see if we have a bad question. And guess what? It doesn't matter if a previous researcher found this to work. All that matters is Regis students didn't understand the question, and like now the scale's all messed up, so we got to get rid of that item. And you tell people that you had to get rid of that item, and it didn't. The Chromebox Alpha was really poor with that item in our sample. We don't know why, and we often realize that there's something unique about our sample, essentially, okay? So that's step number 1, okay? And then I just want to give it a look here. So that's step number 1. That's determining what items go into your final scale. So you do that, and if you find something, then you delete that item from your scale. For example, if I wanted to, and I was like, okay, I got to get rid of item 2, I literally delete item 2 from up here. I probably rename this to 2 and 3. I change my data frame, Q1, Q2, Q3, Q4. And notice you can add as much as you want here. As long as you add it down here, you're fine, okay? But then we have our final data set. And then we're just going to keep it the same. I'm going to rerun it because let's imagine you deleted item number 3. Then you got to rerun the whole thing, okay? So now I rerun my analysis, and what I'm doing here is I see my correlations among all the items. I think this is useful, but you don't make any decisions off of this. You can see you have this diagonal 1, so you're going to have you're going to have the correlation between question 2 and question 1, correlation between question 1 and question 2. It's the same answer, right? And what we can see generally, question 2 is very lowly correlated, but question 1 is highly correlated with 3 and 4. Question 3 is highly correlated with 1 and 4, but not 2. And so if we were going to get rid of 1, it would be question 2. But this, you don't make any decisions off of this. We've already made our decisions. This is just there sometimes to help. Sometimes people want to see it. Okay, this is a correlation matrix, okay? But the thing you got to look at now is your scree plot. Interpret a scree plot. Well, you got to understand what scree is first. Scree is a geological term. So you got a mountain, right? And the scree is like all the stones and rocks at the base of the mountain, essentially. Some of you know better than me about a scree field, and I'm going to let that slide. But in terms of interpreting our number of factors, we find where the scree is, right? And then we look at the number of factors above the scree. In this case, we only have one factor. And that's it, because our questionnaire is a questionnaire of happiness. And so that's great for this questionnaire that I created. But essentially, let's just sort of... So we know there's only one factor in the scale, so we wouldn't have to do anything, right? But let's say that we had kind of like 2 bumps before it like leveled off like this. Not completely leveled, but tapered off, right? So let's say I had 2 factors. And that would look like I might have like a dot here, then it kind of tapers off a little bit, but then this really tapers off, okay? So here we only have one factor, but let's say I had a 2-factor scree plot. And I'll show you some pictures of scree plots and help you interpret them. So then I have to go in and manually change this number of factors that my scree plot gives me, right? From whatever it is to whatever. So in this case, I have 1 factor, so it doesn't really matter. This is called a factor analysis. So this scree plot tells me we have 1 factor. So I did a factor analysis. We have 1 factor. But if it showed me we had 2, right, I would change the number here, and I would run my set of data one more time, and then I go into what I have, which are my, it gives you this R thing. It gives you your factor loadings. So if I had 2 factors, we can notice that every single question has a decent loading on this factor with the exception of question 2. But since there isn't a second factor, you can see that all the loadings on the second factor are really small. So we only really have 1 factor. All of our questions load on factor 1. Question 1 is the most factor 1-ish. Well, actually, question 4 is the paradigmatic question in factor 1. Question 1 is also high, and question 3 is also high. And question 2 has a decent loading on the factor, but it's not super great. We kind of saw the same thing in our Chromebox Alpha. So now that's what we would do. Let's say if we had better data where we had 2 different factors, we would say, okay, actually, let's say that this value for PA2 for question 2 is 0.9. So then what we'd say is like, well, okay, question 2 is kind of in factor 1, but really question 2 is really factor 2, whatever that is. And then we'd say, okay, factor 1 are these 3 questions, and then we look for some commonality. So in this case, we're like, okay, how happy are you? How sad are you? How anxious are you? How peaceful are you? So then, like that second factor, I would call hippie bullshit. Like I would say the second factor is hippie bullshit. The first factor is emotion, and I might get rid of the hippie bullshit question because I'm interested in emotion, not hippie bullshit, right? And I'm not trying to swear for the sake of swearing. I'm just showing you what goes on. Now, that's how you use a factor analysis, right? You look at your scree plot for your questions. You find the scree, the point where the mountain flatten kind of tapers off, right? Still, if you've been to a mountain, you know what a scree's kind of like, right? And then you say, well, this is the point it tapers off, and this is the number of factors we have. We go one up, okay? And that's essentially how it works. If we did a big five scree plot, let's see what that'll look like. Big five scree plot. Maybe we'll be able to find something here. Find something that makes sense. I just want to see what we got here. We got an image. I'm going to go back. Big five scree plot. Well, here we'll just look at this one. Maybe it's not the big five, or if it'll show up. Come on, show up, buddy. Oh, looks like okay. That was fun. That was nice. Here, let's look at this one. So I don't know what they analyzed, right? But you can see that it levels off here. You got this drastic drop. You got a leveling off here. How many factors are there? There are three factors. And look, you can see what they did was they looked at how well items loaded on each factor. And what they did was they said that item one or 7, 1, 5, and 3 were in factor 1. Factor 2 was 4, 8, 10, and 2. Factor 3, they included factor 1, factor 10, factor 2, factor 6, and factor 9. And those are all three different components or ideas of the scale. So essentially, this is this is what you're looking for, right? And now they would create a subscale here, a subscale here, and a subscale here. And I don't even need to know necessarily what it is, but ultimately this is how a factor analysis works. Now sometimes it's hard to determine the screen. You just have to go with your gut, okay? Like if it's really hard for you to tell, show it to me and I can help you make the decision. But ultimately, this determines our number of factors. Okay? And so here we have one factor. I put it in as 2 just to show you what you would get. But ultimately, like you could imagine if this was 0.9, I'd say, well, question 2 loads onto 0.9. That's hippie BS. And then question 1 is emotion, happiness, essentially. And that's and then what you would do is you would go back. Oh, I hope it's still somewhere I can find it. I'm going to guess it's back. No. I'm looking for that big 5 questionnaire one final time. Let's see if I get lucky here. All right, I'm going to go. Nope. Big 5. Big 5 inventory test. Right? And you'll find something like this. And if you look, this is how you create your scoring algorithm. You have to do a factor analysis to figure out these different factors. So the way they figured out the big 5 was the way I just showed you. Essentially, I had a PowerPoint presented, but you know what? It doesn't really matter. What do I want you to do? None of that really matters. Nope, we're all good. I think it just crashed my thing. What I'd like you to do for homework, Here, I'll just write this down. Make sure we get that. I'd like you to ask 5 people 10 questions. I'd like you to try to develop a scale on anything that has 2 or more factors. And I'll explain to you that in a second. That's it. That's your homework. That's it. So you're going to make 10 questions. You want them to load on 2 different factors. So you want to create two different you want to create a big scale with 2 subscales. So let me see here. What's something we can measure? Yes, we can measure empathy, and we can have it for the other and for myself. And so for the other, I'm going to ask some questions that allow me to understand if my empathy is truly for someone else. When I see someone in pain, I think about ways to alleviate their pain, right? That's thinking about the other. And it's okay to make up questionnaires and to test them out and to get a little bit of experience with this process, right? To do this well, you have to go through all these steps multiple times. But let me see here. When I see someone taken advantage of, I often speak up. I often speak up. I will speak up even if I face a personal risk. That's probably poorly worded, right? But then you can see for myself, when I see someone in pain, I actually feel their pain, right? That's like me experiencing empathy through me, not through the other. When I see someone hurt, I worry about being hurt the same way, right? So now I'm trying to create a scale that has 2 subscales: empathy for the other, empathy for the self. This is where I would start. I don't care how good your questions are. Just go through, make 10 questions, and that's your homework.